All right, single digit multiplication. So we'll take a look at a problem like 5 times 49. Okay, when we're looking at this, we're looking at 5 of the 49s. So what does that look like? So let's say you have 49 pieces of candy for one kid, and there's 5 kids, and they each have 49 pieces of candy. How much candy would they have overall? That's what 5 times 49 means. So the way that we do it is by the standard algorithm. The standard algorithm basically means the regular way of doing it, okay? And we multiply the numbers in a specific order. So we take this 5, and I remember I want 5 of the 49s. So that means that I want 5 of the 9s, and I want 5 of the 40s, if I want to find out what 5 of the 49s are. So I'm really doing 2 things here. I'm doing 5 9s, which is 45. And I'm doing 5 40s. Remember from previous video, 5 times 4 is 20. I got that extra 0 there. So together, 5 of the 49s would be those 2 added. So 245 is what the answer would be for 5 times 49. But if we multiply them separately and then add them, that's what we do. So the standard algorithm does that for us, but it does it in kind of a shortcut way. So if we take a look at the standard algorithm, we're going to do the same thing. We're going to multiply, and this time we've got 42 times 6, so I want 6 of the 42s. I'm going to multiply this 6 times the 2. We always start on the right, so 6 times 2, and then I'm going to do 6 times 40. But I'm not going to call it 40, I'm just going to call it 6 times 4. So the standard algorithm shortcuts this. So I'll show you what I mean. 6 times 2, so that's 12, and that's going to be written here. Now, the problem with this is that I'm just about to do 6 times 4, because that's the next step, and I'm going to be writing that down here. But guess what's under the 4? That 1 there from the 12. So what I've got to do is I've got to put that 1 somewhere else for a minute, because it does belong there. It belongs in the tens place. I'm going to move it above here. This is what standard algorithm does. Now the next step is the 6 times the 4, or 6 times 40. So that's going to be here, and that's going to get written down here. Now 6 times 4 would be 24, and that would be written the 2 in the tens place and the 4 in the ones place. 6 times 40 would be 240. So that's why I'm going to write the 2 here and the 4 here, because it would be a 2 in the hundreds place and a 4 in the tens place. Okay? So when I do 6 times 4, I get 24, which I'll write there. But that 1 was supposed to be there. So what I've got to do is add that 1 to the 24. So when I do that, that gives me 25. I cross it off there so I can say that I've added it. And so that's what 6 times 42 is. So let's do another one, because I may not have explained that very well, but let's have a look. So here is a 3-digit number times a single digit. If I've got 5 times 7 first, so this is the order I'm going to be doing it. 5 times 7, and that'll be written here. 5 times 9, and the answer will be written here. And 5 times 3, and the answer will be written here. So 5 times 7 is 35. So I'm going to be doing my 35, but instead of writing the 3 down there, remember, since I'm going to do 5 times 9 and put that there, I need to move that out of the way for the minute, so I put it above here. Okay. So now, the next step is 5 times 9. Well, that's 45, but I have that 3 there already, so if I add that to the 45, cross it off there, that'll give me 48. So my 8 will be down here, and my 4, instead of writing it down there and moving it up, I'm just going to write it up there. So you can see I've got 48. 48 gets written there. The 4 is carried up there. And the last step is 5 times 3, which is 15, and that's going to go here. But I already had that 4 going down there. So 5 times 3, 15, plus the 4, that's going to give me 19. And that gets written down there. Now I don't carry that 1 up here because I got nothing left to multiply. So that 1 will stay down there. So 1,985 is the answer. So that's single digit division with the standard algorithm. There are other ways to do it, but this is the way it's done mostly. And I will be looking at other ways in later videos.